Okay, so this is problem 4 of the problem set of week 5, and we are asked for scalars a and b such that a times vector u, which is given here, plus b times vector v, given here, is equal to a vector with these components. So for solving this, of course we can add it's easier to treat it like a system of linear equations and then solving it with a matrix and Gauss-Jordan. So for example, we multiply a by the first component of u, so we have 2a plus b times minus 2 minus 2b, and this is gonna equal minus 8. Then we will have just a plus 3b, and this will equal 8, and so on and so forth. And we can write this as 5 times 3 matrix, so it's gonna look like 2 minus 2, 8, 1, 3, 8, 0, 1, 3, 1, 0, minus 1, and minus 1, 2, 7. Okay, so sorry, this is minus 8. Okay, so this is alright, and now we can solve this using Gauss-Jordan method. Okay, so first we see we can subtract. We can have first row 1, so we do 1/2 of row 1, and it's gonna look like 1 minus 1 and minus 4. Then we see that we can, oh my god. Okay, so then we see that we can subtract R1 from R2, so we do minus R1 plus R2, also here. So we are left with 0, 0, 4, and 12. And then we can do the same for R3. Sorry, R4. So minus 1, R1 plus R4. Okay, so here is the same. 0, 1, 3. Okay, so this one is 0. Then we have a 1, and then we have a 3, and minus 1, 2, 7. Okay, so we can now just add R1 to R5. So I'm sorry for the choke. Okay, so we're left with 1 minus 1 minus 4 0 4 12 0 1 3 0 1 3, and this is gonna be also 0 1 3. Okay, is it visible? Not so much. Okay, and these rows are all the same, so yeah, we can also divide by 4 the second row, so it's gonna be 1 and it's gonna be 3, also 3. Okay, so we now can subtract the second row from the rest of the rows, and we are gonna have this is the same 1 minus 1 4 0 1 3, and we're gonna subtract this to this, so minus R2 plus R3 which is 0 0 0, and also minus R2 plus R4 which is also full of zeros, and minus R2 plus R5 . Sorry, and also full of zeros. Okay, and so this is our final matrix. No, wait, we are still left with one step. So in this case now we go up. Okay, and subtract this row 2 to row 1, so minus R2 plus R1, so we're left with 1 0 and 1. Oh wait, this was minus 4 before. Yes, I think I made a mistake somewhere, but okay. So we are left with this, and the rest of the rows are zeros, So given these two rows, the row for A tells us that A is equal to -1 and B equals to 3. So these are our scalars that we are looking for, and so we have solved the problem. Okay.